Hello, welcome to the first e-learning class. This is Dr. Muhammad Imran. Today, the topic we are going to cover is aqueous solution and reactions in aqueous solution. First, what is aqueous? The term aqueous has been taken from a word aqua, A-Q-U-A, which does literally means water. So, aqueous means in the water. Well, what's the solution? A solution is a homogeneous mixture of two or more than two substances. This is called a solution. A solution normally does contain two components in it. One is solute and other is solvent. A solute is or are the substances which are present in a smaller or lesser amount in the solution, whereas solvent is a substance which is in higher amount. Now, what is aqueous solution? For example, if I take the bottle of water and I put some sugar in it and I dissolve the sugar, the solution which will be prepared will be termed as aqueous solution of sugar. That's aqueous solution. Anything when you dissolve in water and the water behave as a solvent, water is the one which is in major content, that is solution. Here are given three different examples of solutions. The first one you might see there on your left hand, it's soft drink. Well, soft drink is Coca-Cola, Pepsi, Fanta and so on. It does contain lots of amount of water. So water is act as a solvent in this solution. Whereas sugar, carbon dioxide and taste enhancer, other chemicals, they are all present in a smaller amount. They all known as solute. Air is another mixture of gases, and as we said, a homogeneous mixture is called solution. So air is also a solution, but it is in gaseous state. The air does contain almost 78% nitrogen. That's why because of the major component is nitrogen, we call it as solvent. Whereas oxygen almost 21%, argon and methane in a minor amount. They're all oxygen, argon and methane and carbon dioxide also. They're all considered as solute because they are in a smaller amount. A solution could be solid. A soft solder is an example of that, where solvent is lead and a smaller amount of tin is mixed as a homogeneous mixture. So, aqueous solution does means the solvent must be water and the solute could be either ionic compound, aqueous acid or bases, or the molecular compounds. Table number 12.1 shows you there are different states of the solutions. Some are in gaseous physical state, some are liquid, and as well as some are solid. We just spoke about. Now let us understand what is dissociation. Whenever an ionic compound or acids or bases, we dissolve them in water, they actually break up into their ions, into their respective charges. And this breaking up into the forming cation and anion of those compounds, of those molecules, called dissociation. So dissociation is a process of breaking up a molecule into its ion, and it happens when you dissolve it in the water. But this can only happen with the ionic compound, acids and bases. Molecular compounds do not dissociate into their charges. General properties of aqueous solution. An aqueous solution could be an electrolytic solution or a non-electrolytic solution. And what's electrolyte? An electrolyte is a substance that dissociates or forms positive and negative charges inside water. That means all ionic compounds, acids and bases are electrolyte. Whereas non-electrolyte, all are molecular compound, when you dissolve them in water, they do disappear in the water, but they do not break up into forming cation or anion. And that is why they are called non-electrolyte. An electrolytic solution can conduct electricity, whereas non-electrolytic solution can never conduct electricity. Here are the given information. All ionic compounds soluble in water, obviously we are talking about aqueous solution, that means the solute is already dissolved in the water. Strong acids, strong bases, they are all strong electrolyte. Weak electrolyte are weak acid and weak bases. We are going to talk about why some acids and bases are considered as weak acid or weak bases. There are non-electrolyte, which are all molecular compound. They are called non-electrolyte. Now, molecular compound do not conduct electricity when they are dissolved in water. That's why they are called non-electrolyte. But acid and bases are exceptions for that. The acid and bases, when you dissolve them in water, according to Arrhenius, they breaks up into forming H plus ion if it is acid, and if it is base, it will be OH minus ion, according to the Arrhenius theory of acids. Now consider this photo. Over your left hand side, you see pure water, which is distilled water. It does not have any ions in it. If you try to pass electricity through the water, as you can see there are two electrodes inside the water. We have been supplying a power supply from outside, a battery, so on, and it does not glow the bulb. That means the current will never conduct inside pure water unless there is an ions in it. The next you can see is a molecular compound dissolved in water, which is sucrose. Sucrose is the sugar you eat every day. Now, if you dissolve sugar, sugar may disappear, may dissolve in the water, but it does not break up into forming positive or negative charges, and that is why it will never let the electricity conducted through the solution. Whereas on the right hand side, you can see sodium chloride solution. A sodium chloride is an ionic compound, and whenever an ionic compound is soluble in water, it means it breaks up into forming cation and anion. That's called ionization, and that is why once the ions are formed in the water can easily conduct electricity. A weak electrolyte, majorly weak acids and weak bases, are weak conductors. Well, the reason is that they actually do not dissociate completely into its ions. Rather, a small number of molecules only break up into cation and anion, and rest of the molecule remain in a molecular form. So when they are dissolved in water, only few molecules dissociate into the charges, and that is why they are weak electrolyte. Here is the given example why we call strong acids and strong bases a strong electrolyte, and why they are strong base or strong acid rather than there are some weak acids and weak bases. Take an example of ammonia, the one over here below. Ammonia aqueous, AQ, representing that ammonia has been dissolved in water. That means it becomes ammonium hydroxide. But if you have almost 100 molecules of ammonia inside the water, only few of the ammonia molecule will form ammonium ion and hydroxide ion. And most of the molecule of ammonia remain in a molecular form, because ammonia is forming very less molecules into cation and anion, so they are producing less charges in the water, and that is why they are called weak electrolyte or weak base. The same happens for acetic acid. Acetic acid is a weak acid. If you take almost 100 molecules of acetic acid and dissolve it in water, almost 3 to 7 molecules dissociate into forming acetate ion, NH plus ion. All 97 to 92 molecules remain in a molecular form, which is acetic acid. Because acetic acid giving H plus, we call it as acid according to Arrhenius, but there are very few molecules of acetic acid actually does that process. There are only almost 3 to 7 molecules which dissociate, which gives H plus. All remain of the other molecule stay in the molecular form, and that is why we call it as a weak acid. If we have a strong acid, almost all the strong acid and strong bases does almost completely ionize. That when you have 100 molecules, almost 97 molecule might get ionized, forming plus and minus charges, and that's why, because they are producing so many charges in the water, they are called strong electrolyte. Here are some of the strong acids examples: hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, chloric acid, and perchloric acid. Strong bases. Mostly alkali metals, when they form hydroxide, they are strong bases. Examples are given over here: sodium hydroxide, potassium hydroxide, lithium hydroxide. They're all strong bases. Also, alkaline earth metal, the second A group elements in the periodic table, does also make hydroxide, and they are also strong acids, but not all of them. The few, like calcium hydroxide, strontium hydroxide, and barium hydroxide, they are strong, whereas others are weak bases because they does not dissolve in the water. Let us talk about the concentration now. The concentration is defined as amount of solute in a particular or in a given amount of the solution is called the concentration. That means, let me redefine it. The amount of solute dissolved per unit amount of solution is called concentration. Now, concentration could be expressed into several ways. One of the most famous or important concentration representation is molarity. Others are mass percentage, part per million, and part per billion. First, molarity. Two solutions can contain the same amount of compound but be quite different because of proportion of those compounds are different. All they are trying to say, let's take an example of having 2 cups of water, and we add in the first cup 1 spoon of the sugar, and in the second cup 3 spoons of the sugar. Although both contains the same compound, sugar and water, but they would be quite different when you taste them. The reason is that there are more sugar molecules dissolved in that particular amount of water compared to the first one.